Now we're going to solve a few literal equations. I have two examples here. As you can see, these equations involve more than one variable. So your goal is to solve for one particular variable in terms of the other. Here, for the first problem, let's call this one question 1. This is question 2. For the first one, we're going to be solving for the variable x. So I see x appears right here and here. So we need to isolate and have the equation set x equals to something. Let's go ahead and see how we're going to do that. So I'm going to go ahead and just pull this down here and start working on it. So we're going to go ahead and multiply both sides by the denominator cx plus d. So that leaves us with ax plus b is equal to 2 times cx plus d. And then here I can distribute so I can isolate the x. You have on the left-hand side ax plus b is equal to 2cx plus 2d. Now I see x appears here and here. Let's put them together on the same side. So I'm going to go ahead and try to arrange x terms to be on the left side. So I will subtract 2cx from both sides. So that leaves me with ax minus 2cx plus b is equal to 2 times d. And now I see a b here. I'm going to move that to the other side. So I have everything only involving x on the left side. Go ahead and subtract b from both sides. So this will give us ax minus 2cx is equal to 2d minus b. And now I have successfully placed everything that involves x to the left-hand side. Now I can use the technique of factoring to factor out that x. So you will have x times a minus 2c, because if you now redistribute, you get the step before. So this is good. And on the right-hand side, we just have 2d minus b. Now, finally, since x is multiplying a minus 2c, I'm going to go ahead and divide by that term. So this is divided by a minus 2c on both sides. And that isolates x completely. So x is equal to 2d minus b all over a minus 2c. So there you have your variable x completely isolated. All right, now let's take a look at this problem. Another literal equation. We're going to be solving for the variable r sub 1. So r sub 1 appears right here. So it's in the denominator. Every time you see an equation like this where you have fractions involved, let's get rid of the fractions. So I'm going to go ahead and multiply both sides by the least common denominator, which we call it LCD. So my least common denominator has to be r, so I need to get rid of that denominator. I also need this term, so times r1, and I also need this term, r2. So the product of these three terms will give me my LCD. All right, now let's take that LCD and multiply this entire equation by the LCD. So r times r1 times r2. So I'm distributing it here, here, and here, everything left and right. So on the left-hand side, you'll have r times r1 times r2 times 1 over r is equal to, on the right-hand side, when you distribute, the first term will be, again, 1 times the LCD, that's r times r1 times r2 divided by r1. The second term will give me 1 times the LCD, r times r1 times r2 divided by r2. Now we simplify. Now you could have done this step mentally. I'm showing you more steps so you can see where this is going. For the first fraction on the left-hand side, these will cancel, so get rid of that denominator. Second fraction, well, on the right-hand side, first fraction, this one, they cancel, and these guys will cancel. So this leaves us with r1 times r2 is equal to r times r2 plus r times r1. So no denominators, wonderful. Now let's see which one we're solving for, r1. So let me go ahead and highlight that I'm solving for this variable. So I want them to be on the same side. So I'm going to move r times r1 to the left by subtracting r times r1, r times r1. That leaves me with r1 times r2 minus r times r1 equals r times r2. And now, since both of these terms have r1 in common, you can factor out r1 just like we did before. So you're left with R2 minus R is equal to R times R2. And now finally, since R2 minus R1 is multiplying, R2 minus R is multiplying R1, I can divide by this term, R2 minus R, on both sides. And that isolates my R1 that I'm solving for. This is R1 is equal to R times R2 over R2 minus R. So you see we have now successfully isolated the variable. So our R1 is equal to this expression.